Morning. Math 9 in the PM. Shout out to my man. What's your name again? Yeah, Maddox. Shout out to my man Maddox. And shout out to me and Math. Diamonds and digits. Money.
Diamonds and digits are nailing it today. Hot dog, it's outside class. We're adding rationals, which means fractions and decimals. Decimals are pretty easy to do. And yes, I will allow calculators and stuff like this, but I want you to at least think about this. Yeah, you just add up the numbers, you line up the decimals. But I want to show it. Hang on. I know you're quite a whiz at this. Let's just review for everybody. When I see this, what's in red, 3.25 plus 28.6, I like doing it like I did when I was in grade 4. I stack them because I got to line up the digits. And this is a review. I don't think this is anything new for anyone. Now let's do some arithmetic with how to calculate. So I'm adding up the 5 plus nothing. Right? Hey, that reminds me, nothing. Somebody asked me the other day, what'd you get your mom for her birthday? It's coming up right last year. Or what are you getting your mom for her birthday this year? I said, same thing I got her last year. Nothing. Now she has a matching set. Matching set. Let's move on. Okay, 2 plus 6 is 8. 3 plus 8 is 11. Do you remember the carry the one trick? I'm going to go with it. Okay, that's an example of adding with decimals. I'm making sure everybody's seen this before, right? I didn't do one with borrowing because borrowing is from subtraction, but I did a carryover. Now, a little more work when it comes to, I'm going to just move this up so it's more space. 1/3 or 1/5 plus 3 out of 5. Okay, what is the mind direction? I know Charlotte knows this, so I'm going to just see if somebody else knows. What do we need to do before we can add 1/5 and 3 out of 5? 3/5. Anyway, yeah. What about the bottom? The same because they are matching. We have to make sure that the denominators, the bottoms, are the same. In this case, they are. And I have a picture underneath there to explain why this works. If we have 1 of the 5 squares plus 1, 2, 3 of the 5 squares, and we added this one to this, how much would we have? You can count them, literally, 4 out of the 5, right? So is that too much of an angle? You can. So add the tops to the tops, keep the bottom the same, right? And yes, there's words, numerators and denominators. Huh. I'm going to add that in case you need to remind yourself. Add the tops, numerators. And if the bottom matches the denominator, just write it down. When? Bottom denominator. Okay? Now the real work is if you don't have matching denominators. I'm going to slide up and you'll copy out this next example. Okay? And I'll pause the video in case you're watching on video because a lot of people miss it. Are we ready to rumble, right? Oh, 2 or 3 people start right before. I think we're close already. So if we need a common denominator, meaning the same number on the box, put the phone away. Okay. That means 5 and 15. The first thing you should always look is, can the smaller number multiply up to the other number? Look at the lowest common multiple. LCM, you guys used to call it. I really don't care if you know that name. I do. It's really, does the smaller number, first of all, multiply up to 15? Does 5 go up to 15? If not, there's another way of doing this. First, we'll look at this one. This one does, and I saw people nodding their head. Yeah, 5 times what is 15? 3. So if I multiply the bottom by 3, I have to multiply the top. It is. But I want to explain why this works. It's like, why can I just multiply something in the middle of my equation? What is, I multiplied by 3 over the 3, right? 3 on the top, 3 on the bottom. What is that as a fraction? Just 3 out of 3. 1. 1. You can multiply any number by 1 and it doesn't change, correct? It might make it look differently if I multiply it this way. The reason why you're allowed to just throw in 3s, or 3 out of 3, is because you're multiplying 3/5 by the number 1 in the form. If you don't understand that, just do it, but maybe it helps make some connections with something. So I'm going 3 times 3, it's 9 out of 15. The other one's staying as 2 out of 3. So this is good, right? Because now I have a matching bottom, it's like the previous example. I just add the tops. 9 plus 2 is 11. Right? Now, pause this while we. Next one. So I don't want to see many phones. That's my whole point. What if they're different and they don't easily, well, 4 doesn't turn into 16. You still need a lowest common multiple. You can think about it. What is the number? Yeah, and you know it, right? What is it? Good, 12. And some people do it like trial and error kind of thing, like they just try, okay, if I look, yeah, 12 works. You know, if you're really stuck, you'll get too big a number sometimes. But if you're really stuck, in this case, you just multiply this whole thing by 4 and a 4 and 6 out of 6. It'll be 24 though, and you'll have a bigger number than you need, not to reduce the fraction faster. But it always works. But think about it. Think, what number does 6 multiply up to? What number does 4 multiply up to? And they're the same. 12 is smaller, so you want smaller numbers. Thank you. It's done. I'm going to write that down, what you said exactly. He said multiply by 2. So I'm multiplying by 2 over 2. That's a form of 1. You get a 12 on the denominator. I'm multiplying by 3 out of 3. It's a form of 1 to get 12 on the denominator. Now we're putting with gas. Times the digits. We're talking. I go 1 times 2, 2 out of 12. Plus 3 times 3, that's 9. I'm adding 11 out of 12. That's fine. This should be reviewed, right? There's nothing that's new here today. Is that correct? It's reviewed. And I already have the answers there. I want you to work on these problems right now for the rest of